Hello, and welcome back to another lesson in encouraging engineering. Today, we're going to use a passive buzzer through an ultrasonic sensor. Before we start, let's talk about the components we'll be using in this project. Passive buzzer is a small speaker that uses a DC current to produce sound. Arduino allows it to play at several frequencies, allowing it to make varying sounds. It's very simple to set up since it only has two pins, with the positive sign being marked by a plus sign. The other pin should be connected to the ground. An ultrasonic sensor is used to measure distance by emitting a high-frequency sound wave and measuring how long it takes for the wave to return. It does this through its built-in transmitter and receiver, which are marked by the trig pin and the echo pin respectively. The transmitter is responsible for emitting the wave, while the receiver detects the returning wave. Like the potentiometer in the previous lesson, there are different types of ultrasonic sensors available, and this lesson will use an HC-SR04 sensor. Make sure to look up the component and wire it correctly if you're using a different type. Before we start programming, set up the circuit as shown in the picture here. You need one Arduino board, one breadboard, 8 wires, one passive buzzer, and one ultrasonic sensor. Make sure to set up the pins correctly and pause if you need to. First, let's make the variables for this project. The first two variables will mark the trig and echo pins for the ultrasonic sensor. The other two variables, time and distance, are needed to use the ultrasonic sensor. Notice how we mark the variables as float instead of integer. When we work with variables using decimal numbers, we need to mark it as a float variable. Integer is only used to mark whole numbers, and if we try to mark the time and distance variables as integers, we'd get an error message in the code. The last variable should represent the buzzer pin. In the setup function, we're going to set up the buzzer and trig pin as the output. Since the trig pin, or the transceiver, is putting out the sound wave, it's considered an output in programming. The echo pin, or receiver, will take in the sound wave, so it will be considered an input. Since the other variables aren't connected to a component, we don't need to use the pin mode function for them. In the loop function, we'll start by having the ultrasonic sensor create a sound wave. We only need to know if there is voltage or not, so we'll use the digital write function. Also, the trig pin is responsible for generating the wave, so we need to use this variable. To make the sound wave, we'll have the sensor generate a sound wave for 10 milliseconds using a delay function. After 10 milliseconds, we'll use digital write again to turn off the trig pin. The ultrasonic sensor is capable of measuring the time it takes for the sound wave to return, but it doesn't know how to use this data to determine the distance. This means we need to do the calculations in our program to know the distance. To store the time it takes for the wave to come back, we'll use the time variable we created earlier. To get the data from the sensor, we need to use a special function called pulseIn. Using this function allows us to time the duration of a high or low value of a pin. For example, if we set up the pin as pulseIn echo pin low, the Arduino will start a timer when the echo pin reaches low. When it starts to reach as high, the timer will immediately stop. In this case, we want to time how long the sound wave is detected by the echo pin, so we'll put pulseIn echo pin high, which will time when the sound wave is detected and how long it lasts. We'll set this equal to the time variable. With this data, we can calculate the distance determined by the sensor. To save time, you can just copy the distance formula here on screen and set it equal to the distance variable. It's important to note that the distance is measured in centimeters. If you're curious about how this equation works, I left a link in the description for a better explanation. Now that we have the distance, we can start making a conditional for a buzzer. For this lesson, we want the buzzer to sound when something is close to the ultrasonic sensor, and turn off when nothing is detected. For our first condition, we'll put that the distance must be less than or equal to 10 centimeters for the buzzer to sound. Underneath, we'll use the tone function to create noise. For this project, we'll put the tone at 50 Hz, but the buzzer can make any sound between 32 to 4,978 Hz. If you want more details on the tone function and its limits, there's an article in the description for reference. Using the delay function, we'll have the buzzer play for 10 milliseconds. Then, set the distance variable to 0. If the distance detected is not less than or equal to 10 centimeters, Then we'll turn off the buzzer by using the tone function. We set the distance variable to 0 earlier, so we can turn off the buzzer after it goes off. Avoiding this section of code would make the buzzer go off infinitely until the circuit is turned off. Once you finish this section, plug in your project and test it out. If your project doesn't work correctly, here are some ways to troubleshoot the problem. Checking the Arduino is properly connected, checking the circuit is set up properly, and checking that the code is correct. Make sure to see if variables are assigned to the right pin slots. Also, remember to try the serial monitor to check certain variables like distance and time. We discussed how to use this in Lesson 2, but you can check the slides or link in the description if you need a refresher. If none of these recommendations work, take a break and return to the project later. It's better to troubleshoot with a clear mind. If you're interested in expanding your knowledge, some alternative projects could be playing a song with the buzzer when the sensor goes off, lighting an RGB based on the distance detected by the ultrasonic sensor, and playing different tones based on a potentiometer. Some of these projects are based on previous lessons, and I recommend you check them out as well. That's all for today's lesson. I hope you learned something new, and I encourage you to keep learning on your own. Have a good day.